this number to the right and x squared to the side. Okay? And then that gets rid of the square root. And then just combine it. Now x is mx. And then you got x squared. Positive is going to be x squared minus 2x.
That's negative though.
I didn't even for bioengineering. You already
Alright guys, take a look. Alright, on this first one, it's related to the idea of rationalizing. And you should have seen where you don't always rationalize the denominator, sometimes you rationalize the numerator. Let me point one thing out about this expression. What happens when you let x be 2? 0. No? No? X is 2, the top is 0, but the bottom is also 0. Anything 0 divided by anything is 0. Anything divided by 0 is undefined or infinite. So you have something that is both 0 and infinite. Bullshit. So we call this is worse than undefined, it's called indeterminate, and it's going to actually be a huge topic we're going to discuss later. So the only problem point here is 2. That's the only way the bottom is 0. You guys with me? So if I can rewrite this in a different way, I might be able to get rid of that problem. Some of you guys who did this, you noticed something canceled, which was 0 when x is 2. So how do I do rationalization here? I multiply by the conjugate, which is really just the same stuff. It's like the difference of squares buddy, right? So you multiply top and bottom by square root of x minus 1 plus 1. That's the conjugate. We do the bottom first. Square root of x minus 1 times square root of x minus 1 is x minus 1 is kind of nice. Half of x minus 1 times another half of x minus 1 makes a whole x minus 1. Oh. So that's x minus 1. The middle terms cancel by design. And then what's negative 1 times 1? Negative 1. So on the bottom I get x minus 2. On the top I get x minus 2 times business. So remember, what was the only problem spot was when x is 2. I get 0 over 0. But now we see more explicitly why that happens. When am I allowed to kill these when x is not 2? So everywhere else except 2, this is equivalent to this. And what is this at 2? When you plug a 2 in, what do you get? 2. And here, just to really mess with your minds a little bit. So, do you notice, can anybody tell me, anybody remember, how is this the radical, the square root function, but how would the graph be moved? How would it be translated?
We shift it to the right one.
This would move it to the right one, up one. So now watch. Oh shit. If I put in here, the original problem, x minus 2, divided by square root of x minus 1 minus 1. There we go. I graph this sucker. Ooh. Exactly like we said, right one, up one, right? So that's showing you that that is equivalent to this. But watch this. I don't know if you guys know how to do this. It's second calc value. You you can put an x value in, it tells you what the output is. If I put a 2 in, what's the output? There's an open circle there, isn't there? We know that because x can't be 2. But tell me, what does it look like the function is going to? As you get closer and closer to an input of 2, it looks like it's getting to 2. It looks like it's going to 2, which is what our algebraic work verifies. That's the idea of limit. I can't plug a 2 in, so what do? I try to either algebraically manipulate it, or I can even make a table of values and just say, when I get really close to 2, what does it look like it's doing? It looks like it's going to 2. That kicks so much ass. Problem spot. Don't go there. Get really close. That makes sense. All right. Yep. Now this one, it's kind of a quick way to do this one. If it was log base 2 of 8, that would be 3. Because the answer to a log is a what? The answer to a log is a exponent. I like it. It's a power. So it's the power that the base needs to become the inside. If it takes 3 2s to multiply to be 8, what do I have to do? How much do I have to break 8 down by? 1/3. The cube root of 8 is 2. And of course, we all know that fractional powers are related to roots, which really don't make sense. What's the square root do to something? Cuts it in half multiplicatively. Where do I put stuff that's related to multiplication? In the exponent. So another way to do this a little more directly is to go, okay, what does this equal? I don't freaking know. How do I rewrite this? 8 to the x equals 2. You guys remember this stuff? 8 is 2 cubed. 3x has to equal 1. So x is 1/3. That took a long time, but oh well. That's a valid way to do that problem. It's just showing you the cube root of 8 is 2. It's amazing. Real quick word about logarithms. What's log base 8 of 64? 2. That's amazing. What's log base 8 of 8? 1. What's log base 8 of 2? We just did 1/3. And what's log base 8 of 1? 0. What's log base 8 of 1/8? Negative 1. You've got to flip 8 to make it become 1/8, and a negative power flips. Notice how if the argument, if the inside is between 1 and the base, the answer is a fraction. Because I have to cut 8 down, but I'm not flipping it. The minute you get below 1 is where you get stuff that has to be a negative power, because then you have to flip it. Because it goes below 0 now. I don't know if you guys ever saw that. You remember logarithms? Oh, shit. Okay. Logs are not difficult. I hate that everybody thinks they are. They're just like saying to yourself, what power does this thing need to become that? Okay, great. I got many ways to attack that now. This one. Okay, don't take this wrong. But this makes me cry so much when people say the answer is 2x+8. I know a lot of people did. But my favorite counterexample is, are these equivalent? Yes, those are all, yeah, the other way to say, another way to say 13 is 4 + 9. And if you think that this is 2 + 3, well then you're saying the square root of 13 equals 5. That's, and I don't want that math getting all up in my math. My math is right. This is bullshit. So radicals are powers. Powers do not distribute across addition because powers are not based on addition. They do distribute across multiplication because they are based on multiplication. You guys with me? A little bit? Tiny. So what I can do is I can rewrite the inside into a multiplication problem. And what's the square root of 4? 2. What's the square root of x squared + 16? I don't freaking know. There, done. Please be done. So many people make problems so easy by doing this equals 2x + 8, and then you do some more stuff. But it made it really quick to get a completely wrong answer. So don't get overly optimistic about simplifying these radicals. Now, if I had square root of 64x squared, what's that? 8x. I could argue it's 8 absolute value of x, but 8x is fine. Okay. So when it's multiplication, radicals can distribute across those all day long. Why? Because radicals are based on multiplication. All right, how are we doing so far? Just remembering it? Is it coming back? All right. Being a little less overwhelmed? What about this? I notice a lot of people leaving this one. I mean, the first thing you want to do
Get out the number.
and of course we probably don't have to write this down, but that's x times x minus 4. So what's this middle dude need? He needs everything, right? So this will be 15 over x times x minus 4 minus 2x times x minus 4 over x times x minus 4. You guys with me? So you give this guy everything, because he ain't got shit. He's just over 1. And what's this guy need? X. Then you can cancel the bottom. Since it's an equation, you can multiply by that denominator and kill them. Are you guys with me? Now, of course, when am I allowed to do this? As long as x is not equal to, as long as x is not, what makes the original problem undefined? 0 or 4. So assuming x is not 0 or 4, what I just did is legal. If I get 0 or 4 as an answer, I must throw them out, because I assumed there wasn't that. How are we doing so far? Is this? You guys all right? So you guys are not asking questions. You got shell shock. But 15 minus 2x squared plus 8x equals x. So, just to cut to the chase here a little bit, if I add 2x squared over, subtract 8x, subtract 15. Some of you guys might have done quadratic formula. Does this factor though?
It's a king.
So watch, twice negative 15 is negative 30. You guys remember that? Negative 30. What factor did that make negative 7? Negative 10 and 3. Right? Let me see if you guys get what I'm about to do. You can break the middle term up and group it. One thing I really don't want to see is divide this shit and do magic. You better be able to explain every step you do in a problem. Watch this though. 2x squared is 2x and x, right? How would I make minus 10? If this is a minus 5, there's minus 10. So then that's got to be a 3 there. Good man. Yes?
How are you crossing all of them out with the 1 over x minus 4 right?
So what did I multiply both sides of this equation by? I multiplied by x times x minus 4, so they all cancel.
But
Distribute.
oh, you're making the left equal to the right.
No, it is. They are equal. So how do I kill fractions in an equation? I multiply by the LCD. If I make them all the same already, they basically all just go away, because I multiply both sides by that. So all the bottoms cancel. Does that sound familiar? No. So, if I have x over 6 minus 2x minus, well, let's make this one. It doesn't matter. Let's make this 6 equals 1/6. What can I do to make that look much better? Multiply everything by 6. Because everything's being divided by 6. So if I multiply by 6, it cancels everywhere. Is that cool? Alright, that's exactly what I did here, except it's not 6. What's on the bottom of everything though? X times x minus 4. So if I multiply both sides by x times x minus 4, they all cancel. Exactly the way this does. Yes, sir?
Isn't the bottom of the second half of that equation just x minus 4?
What did I do though? I multiplied by what it was missing. Right? That's why there's an x there. Same thing I did in the middle. What did I do to the middle guy? I gave him an x times x minus 4 on the top and bottom. Is that cool? You guys really don't like this problem. Let's do this problem again. Here we go. Yes, sir?
Shouldn't it be positive 15, not negative 15 in the
No, see what I did was I added 2x squared, subtracted 8x, subtracted 15.
Oh, you want to
Because it's
okay.
easier if my first term is positive. You guys should have picked up on that. Alright, let's try this one again. Alright, let me be more explicit here. So, what's this guy missing that the other guys had? Everything. So that's completely legal as long as x is not 0 or 4. And what's this guy missing? X. Now, everybody's got a 6 on the bottom. Not really, but it's the same idea. Everybody's got a blank on them. They all have the same bottom. And it's an equation. So I'm allowed to multiply both sides of the equation. I can multiply both sides of the equation by 11.82. I won't. It won't help me. What will help me if I multiply both sides by what's on the bottoms? Because then all the bottoms cancel. So if I make all my terms have the same denominator, they effectively go away in an equation because I can multiply both sides by that. Yes?
But if you're multiplying both sides by something different, then
No, I can't. You're right. I can't multiply both sides by something different. I'm not going to, and I haven't. Now watch. You ready? All right. Did I do anything to either side of the equation? No. I did something to the top and bottom of a fraction, so both sides. The top side, the bottom side. Isn't 2 equal to 2 this over this? Aren't they equal? So I just rewrote what 2 is. There's 2. Well, this is 2 also, isn't it? And then I rewrote that as 1 over x, and this. So I didn't do anything to both sides yet. I did something to the terms, because they're fractions. I'm allowed to multiply, divide, top and bottom by anything, except 0. How are we doing so far? Yes?
So on the right side of the equation, you don't need to multiply by x minus 4.
Oh, this guy.
Yeah, I know it already has it, so you just multiply.
Exactly. You only multiply by what is missing. If I gave him another x minus 4, everybody else needs another x minus 4, right?
Yeah, I guess that makes sense.
I always think about it like, you have kids, you got more sprinkles than me. Oh, no, he's got more sprinkles than me. I just eat all the ice cream. It's all good. No, fine. I used to say it's good I don't have kids, but now my girlfriend has kids, so now I gotta be good. Is everybody decent now? I mean, now this is what we did earlier. If I multiply by x times x minus 4, they all cancel. I can only do that because it's an equation. I have 2 sides to balance out what I've done. Okay, so then we end up with 15 minus 2x squared plus 8x equals x, and then it goes from there. And what answers do I get? Did I get 5? -3x. Careful. And are either one of those something that makes the original problem freak out? No. I didn't get 0 or 4, so they're at least both good that way. Ooh, that was a painful one. Really should have been. That's alright. Hopefully it's coming back. Caroline, give me an eye. Shut up. Alright, I need scores. What about this guy? The biggest mistake, just to stop you if you want to say this out loud, is to square it the way it is. That would so desperately suck. If I squared it the way it is, let me do that over here. If I squared both sides, I have to FOIL this side out. There's 2 terms. I can't just square each piece. I know I can't do that. I have to FOIL it. So what's the first thing I should do?
Root the 2.
Yeah, so I always call this like tyrant class. When I teach this in pre-calculus, I'm like, or math 110, I'm like, this is teaching you how to be a tyrant. You have a country, you have a radical element, what do? Isolate the radical element and then kill it. Right? So, is my radical element by itself? No, so I better get this sucker out of the way so that no innocent 2's are killed. And then I drop the, what? Drop the square bomb. So now my favorite thing in the world is people just say this is x squared plus 1 or something. is x squared minus 2x plus 1. Now real quick, x minus 1, is that positive or negative? X minus 1. Is that positive or negative? I love it. Your answer should be, I don't know. Because what if x is 0? Then what's x minus 1? Negative. So whenever there's an x in something, you're basically, if I'm asking you what is it, you should go, I don't freaking know. I don't know what x is. So is x minus 1 positive or negative? I don't know. When I square it, though, the answer becomes positive, which is one reason why, which is actually the reason why, you sometimes get answers to radical equations that don't work. Because we just lost information about if the radical equal to negative or not. We squared both sides. So just in case you wondered why math gives you wrong answers sometimes, it ain't math's fault. It's math going, dude, you did something freaky? That's the only way you can talk to us. It's to give me bogus answer. So I can't remember if that happens here. So here I subtract 3x, subtract 1. This always freaks people out, but how do I factor this? So then I get x is 0, 5. And see exactly what I just said happens. If you plug a 0 in, does it work? Said so confidently, but so wrong. When you plug a 0 in here, what do you get? You get 1. Minus 2 does not equal 0 minus 3. So when you plug a 0 in, it does not work. You're not allowed to plug a 0 in anywhere in your work you want to. You must always plug it back in at the original problem. Why? Because when I squared both sides, I effectively made a new problem. And some of the answers to that problem might be the answers to the original question. That's why you always got to check your work with a radical equation. So does 5 work? So 0, cross it out. Does 5 work? Square root of 16 is 4, minus 2 is 2, 5 minus 3 is 2. Yay! Circle that. Is that? Don't write the 0. I mean, write it and show me that you cross it. Now this shouldn't necessarily show up directly, but this kind of thing still does happen in calculus. All right, how does everybody feel about that one? Any questions on that one? What's your guy? All right. What about this dude? How many terms are there here? 2. 1, 2. Separated by a minus sign, there's 2 terms. I like it. What number comes out of both? 3. How many m's come out of both? 1. And how many m minus 5's come out of both? 3. So what's left? 6 divided by 3 is 2. I had 2 m's, I took 1. I had 3 m minus 5's, I took them all. 21 divided by 3 is 7. I had an m, I took it. I had 4 of these, I took 3, so I have 1 of these left. And then you just clean up the inside here. Let's see what it is. Negative 5m minus plus 35. So then I end up with, take a negative 5 out. Are you guys semi with me there? Let me stop there for a second. This should not be a big deal problem, but somehow it ends up being a big deal problem. Yes? Oh, sorry. But the mistake people make is, like, they think there's too many terms, so you end up with too many pluses and minuses. Or you just overthink what's involved here. I see numbers, I see m's, I see m minus 5. So then it's all just how many of each can I take out? And then writing what's left in each term. That's all this is, just a GCF. You guys with me a little bit? Some of you guys are like, what have I done to myself? And then to finish this, take a negative 5 out. And this would be m minus 7. Is that cool? Because I can take a negative 5 out of here. And then I would have m minus 7 left.
So when you factor 3m, don't you still get that?
Yep, totally. There it is. 200. So the first term becomes this, minus the second term becomes this. Sweet. So it's all about what all shit can I take out? What is left in each term? It's just a GCF problem. It looks worse because m minus 5 looks like it's more complicated, but it's just how many m minus 5s does it have? Just like how many m's does it have? It's the same thing. Maybe. Alright, and then our favoriteest factoring form ever. Oh, saw a lot of blanks there. Yeah.
So I get the first step, like, from the second step.
So now distribute the negative 7. 2m minus 7m is negative 5m. Negative 7 and negative 5 is plus 35. Yeah, so just clean that inside up. And then you see that you're not done factoring because the negative 5 comes out. Bam! Negative 5 comes out, and you see what's left. A rocket. So if I asked you, where is this expression equal 0? For what values of m is it 0? What's true? What's values of m? What values of m make this 0? 7, 5, 0. Everybody always forgets about the portable dude there. If m is 0, this is obviously 0. Yes?
So on the last step, you divided the second part by the negative 5.
Should get negative 5 out. Totally. If I take a negative 5 out, it's going to go to the front. That's just where we put our whole numbers.
Oh, right.
Yeah, or in this case, interval. Yeah, because now it's a free-floating thing. I can just multiply it by whatever it goes with. I like it. I like it.
Where's the fourth?
Say again?
Where is the fourth?
Which 4? Oh, that fourth power?
Yes.
So how many m minus 5s did I take out? 3. That's why there's no m minus 5s here, because I only had 3. He had 4 m minus 5s, but I took 3 of them. So how many should be left in this one? 1. If I take 3 m minus 5s out, and that second dude has 4, he should have 1 left. So it is just a GCF problem. It just, the minute I make it m minus 5. Now real quick, since there's a lot of questions on this one. Watch this. Here's the same problem. The m is really freaking out. How do you factor this? Take out a 3 m y cubed. But you see how that, doesn't that feel easier? Can everybody see how they are the same flippin' problem?
Yes.
3 things I don't know. 3 things I don't know. 4 of that same stupid thing I didn't know. 4 of that same stupid thing I didn't know. It's just when you write it m minus 5, your brain goes, more shit! You should say, brain, no. M minus 5 is one thing. It's going to work just like if it was a y. In fact, this is actually a valid method. Let y equal this. Work it out, and then replace y with what it was. That's called the substitution method, which is going to become a calculus method for doing stuff towards the end. It's like one of the last things we'll learn. Yes, sir?
What do you mean by GCF?
Greatest common factor. Not good children fly or go canoe. F for some reason only becoming one word right now. I don't want to necessarily talk that one. So how do I do Q's? When I teach this, I teach little dude, big dude. And it's just like squares. What do I do with squares? I cut them in half. So what do I do with cubes? Cut them in 1/3 and 2/3. So in the little tiny dude, he's little, only 1 of each goes in there. So that means 2 of each go in the big dude, so you get 3 of each at the end. I don't know if this is jiving at all. So 8b cubed is made up of 3 what's? What's 8? Yeah, so 8b cubed is 2b, 2b, 2b. Good Lord in heaven. 2b, 2b, 2b. There you go, buddy. And what's 27w cubed? 3w, 3w. It's all multiplication, right? So then in the little dude goes 1 2b plus 3w. which means the only way I can make 8b cubed is if I put the other 2 there. So 1 of these, 2 of these make 3 of it all. So what goes here? 4b squared. What goes at the end? 9w squared. Has anybody ever seen Pulp Fiction? Alright, so I relate this problem to a very specific scene in that movie. If you never saw this movie, you don't like this kind of movie, too bad. There's a scene where they have the dude in the back seat, they go over a bump. There's a gun pointed at him, his brains fly over. So they have to call who? Who remembers? The wolf. And what's his job? He's the cleaner, right? He's literally the cleaner. So the middle dude is the cleaner. He's the guy that's going to get rid of the shit you don't want. He's going to clean all the brains and blood off the seat for you. Because, notice, don't I get 8b cubed? Don't I get 27w cubed? But don't I also get flipping 12wb squared? Do I want that? No, that's the blood. And don't I also get 2b times 9? Don't I get 18bw squared? Do I want that? No. So the middle dude has to be the opposite sign so he can do his job and cancel the shit I don't want. Now watch, real quick. Let me see if I can convince you guys. So the extra shit I get is this stuff here, right? You guys with me? That's the extra shit I get from the FOIL. So what would I multiply, what would I have to put here? What would I multiply 3w by so that this would die? 3 times what is 18? So it would be negative 6. And then it needs one more w and a b. I didn't give myself enough room. So the middle dude, the shortcut is the middle dude, opposite sign, this times this. That will always be, create the terms that will kill the other terms you don't want. Why is it more complicated than squares? Well, because now I got 3 of everything instead of 2 of everything. But it's the same kind of idea. So if I do this, I get minus 18 bw squared die. And I also get 2b times negative 6wb is negative 12 wb squared die. So then I only end up with the shit I want. Does that make sense? So this is the most hated form of factoring because it's a form memorization instead of sink your teeth into factoring numbers and shit, right? This is more like, you got to remember where things go. Andy? Yes?
So how do you solve to get the extra shit?
Oh, okay. So again, let's do another problem. The middle term is always the product of what's in the little dude. Always. So if I had this problem, x cubed minus 125. There it is. Little dude, big dude, because it's a cube. X, and what's 125? 555. 1x minus 1,5. The other 2 x's, the other 2 5s. What sign is the middle term going to be? Plus, so you can clean up the shit. And then what's going to be the middle term? 5x. So 1 of each, 2 of each product in the middle. That's the closest I'll get to. So I'm good. Okay. There's a lot of songs out there. Most of them are shit. And for example, I was telling somebody, I hate FOIL method. I wish we never taught FOIL method because the minute you have more terms, it goes to shit. What is FOIL? Repeated distribution. I'd much rather just teach that. Why make it seem like this is impossible until you remember FOIL? No, I don't want to make people feel like that. SOHCAHTOA is another thing I wish would die. If you learn sine likes y, cosine likes x, everything is easier after that. You don't need SOHCAHTOA. You have a lot of, ooh, Camp SOHCAHTOA, I got a shirt. But it's really unnecessary. It makes it feel like, well, this is so hard, they had to come up with this neat little saying to help me. No, it's not that hard. And it's much better for you to remember sine likes y. Where's sine biggest? When it's on the y-axis. Because it likes y, right? Cosine's biggest on the x-axis. Because it likes x. Does that make sense? And real quick, while I'm thinking about it, this is kind of cool. Since I'm talking about trigonometry, I don't know if you guys have ever noticed. What's sine of 0? Let me do radians. Yeah, 0, because there's no y piece there, right? Now watch. What's sine of pi over 6?
1/2.
1/2. So let me write it like this. Square root of 1 over 2, which is 1/2, right? And this is square root of 0 over 2, which is 0. What's sine of pi over 4? Square root of 2 over 2. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2. So what's sine of pi over 3? Square root of 3 over 2. What's sine of pi over 2? Square root of 4 over 2, which is freaking 1. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2. It's really beautiful. Has anybody ever shown you that?
No.
Yes, cool. I like it. It used to only be me, but now it's... And the cosine just does the opposite of this, right? Kind of kick ass. And you don't have to worry about the first quadrant, because since sine likes y, it'll be positive or y is positive. Since cosine likes x, it'll be positive. Everything makes so much more sense, hopefully. Yeah, unicircles, yeah. Okay. Where did I put my darts? Want to get a little bit into Alright, so here we go. Here's our, my answer's up there, sort of. What quadrant is this in? Second quadrant. What's your reference angle? Pi over 3. Because you're a third of a pi away from a whole pi. So what is, of course y is positive, so the answer is going to be positive. So the answer is going to be the same as sine of pi over 3. And what's sine of pi over 3? Pi over 3 is 60 degrees, but that's not the question. Square root of 3 over 2. Sorry, I didn't mean to yell at you. I did a little bit. And so since sine likes y, it'll be bigger when it's closer to y. Bigger positive, bigger negative. So simple. Instead of just straight memorization, make what you remember match the idea of the thing, and it sticks in your head better. It's not memorization, then it's just, here's why it makes sense. What about this dude? Oh, sorry.
Should I turn the camera?
Oh, thank you. Yeah, I need to hire a camera person. There's another good reason why you don't want to make this an online course, because I remember the first time I taught, I put my water bottle down in front of the camera. Everything looked like it was an Escher thing, like. What quadrant is this in?
3.
Yeah, it's past 180. How much?
45.
45 degrees. So my reference angle is 45 degrees. Tangent at 45. Tangent, of course, is defined to be the ratio of sine and cosine. And sine and cosine at 45-degree angles are effectively the same, just different signs possibly. So is this going to be 1 or negative 1?
Negative.
Because here they're different signs. I love it. Bam! Just so you know, the first test, there will be 2 parts to it. One part you'll be able to use the calculator, and the other part you won't. That makes this kind of thing, this would be enough work because you don't have a calculator. I know it's coming from your brain. Okay. What about, I love somebody asked me, do we have to memorize over 12 angles? And I don't blame you for asking, but hell no. This is related to an identity. Cosine squared theta minus sine squared theta equals what?
Isn't it plus sine squared?
Nope. So I'm not trying to make this equal 1. What's 2 sine theta cosine theta? Anybody remember? It's equal to sine of... Okay. What's cosine squared minus sine squared? Cosine 2 theta. Oh shit. This is on that trig expectations sheet. I have no problem putting this down and just assuming you know the identity to use. Because I'm evil. I'm a math teacher. I'm evil. My evil class, I got A++. So this I can write as cosine of twice this, which of course is 5 pi over 6, which is an angle you know. Of course, what quadrant am I in? Is everybody cool with that first step? The identity is cosine squared minus sine squared is cosine of twice the angle. So this is cosine of twice 5 pi over 12. This is 5 pi over 6. What quadrant am I in now? Second. Cosine is what there? Positive or negative? So it's negative cosine of pi over 6. And what's cosine of pi over 6? Pi over 6 is close to the x-axis. The bigger one, so it's negative rad 3 over 2. Woo! Oh, shit. I will give you this. That's one of the supposedly more obscure identities. It shouldn't be. It should be just as big as sine squared plus cosine squared. If you don't know that one, sine squared plus cosine squared is what? As long as they're the same thing. So this one, I just gave this one away. But you can do this 2 different ways, to be honest. I'd rather do it the way that has less work. So it's twice sine. Cosine is sine of twice the angle. So this is the same thing as sine of 7 pi over 3. Now you could do sine of 7 pi over 6, cosine of 7 pi over 6, multiply them, multiply that by 2. Right? If you did that, you're fine. Or you can make it this. Where's this end up? 6 pi over 3 would be 2 pi. So 7 pi over 3 is pi over 3 past that. And what's sine of pi over 3? I like the way you said it so confidently, but no. Right? Pi over 3 is closer to the y-axis, so it's going to be the bigger one for sine. Okay, maybe. Even if you did not remember that, right now this should sound vaguely familiar. If it doesn't sound vaguely familiar, then you might want to come see me. But these are the kind of things I'm going to put down and feel completely fine doing it. Not just because I'm an asshole, but because this is what you should know coming in. Yes?
So why is it 7 pi over 3 again? Just to make sure.
Oh, twice sine theta cosine theta is sine twice theta. That's that double angle formula. So I just remake, that's twice sine that, cosine that, so it's sine of twice that, which is 7 pi over 3 because it's 2 into 6. Cool. Now, did anybody do it the other way, get the same answer? Like you did sine of 7 pi over 6, and you multiply by cosine?
Yes.
You should still get the same answer. That's completely acceptable. I like it, I like it. Because personally, I like to do things the way that takes less work. Everybody get this last thing? What's the output of, I'm sorry, let me say it like this. What is the input of cosine understood to represent? Input of cosine is understood to represent an angle, okay, right? Could be radians, degrees, whatever. Is everybody with me? So what's the output of the inverse function? An angle, right? Inverse functions just take the domain and range and flip them. You guys remember the x and y flips? So the input of a cosine is an angle. The output of an inverse cosine is an angle, which means I can draw a triangle that represents that idea. What that's saying is, draw a triangle where the cosine is 2 over x. And then you can answer any question on the outside. I don't know if this sounds familiar to anybody. So, what triangle, we call this theta, here's theta. Where would 2 and x have to be so the cosine of this is 2 over x?
2 would be on the bottom,
2 should be on the bottom,
and x on the hypotenuse.
x on the hypotenuse, I like it. And how do I get cosecant? Cosecant is reciprocal sine.
This one.
So what am I missing?
The opposite.
This guy. Alright, so this would be, how do I get this side? Good old Pythagorean, right? This would be the square root of x squared minus 4, right? Because I know the hypotenuse is going to be a subtraction to get the smaller leg. And now I can make it, and now I got a cosecant out there. I could have had anything. I can make whatever ratio I want now because I got a complete triangle. So that's the idea with those kind of problems. You can draw the representative triangle, and then that has that angle in it, and then answer. So what's the cosecant going to be?
Root x squared minus 4. Oh, sorry.
Say again, sorry. Say again. One more
X over root x
X
squared
over?
minus 4.
Root x squared minus 4. Because it's 1 over sine, and sine would be y over the hypotenuse, so just flip it. You guys like that? Yes. Oh, leave it like this. Yeah, this is what I want. Rationalization would just not make it any better at all. Okay. So make sure your name is on those and go ahead and pass those up to me.